All right, everyone. Sorry I couldn't be in class today. We are going to do lesson 11.2 extension, and this is on inverse of functions. So sometimes you'll be given some points, and you can basically just flip the x's and the y's. So essentially, normally we have x and y. For the inverse functions, all of our points are basically going to switch values. So here's an example. So if we have -4, 7, that's 1 point. -2, 4 is another point. 0, 1 is a point. 2, -2 is a point. And 4, -5 is a point. And so this is in our regular function. Okay, and we want to find the inverse of this relation. Okay, and actually, so I'm sorry, this is not a function. This is a relation, meaning it doesn't actually have to pass the vertical line test. Okay, so our inputs might have multiple outputs. So, but when we go to write that, basically my inverse, I'm going to switch the 7 and the -4. So that goes there and that goes there. And so I'm going to do it again. So this is now 4 and -2. And so now this is 1, 0. We have -2, 2. Okay. And then what would this one be? -5, 4. Okay. So let's talk a little bit about what the domain and the range were and what they are now. Okay, so this is for the inverse. Okay, so our domain values refers to all of our x values. So it was -4, -2, 0, 2, and 4. Okay, those are our domain values there. These values are no longer in the domain for the inverse, but instead they are now in the y values, which is the range. Okay, likewise, the range is now in the domain. So we're basically flip-flopping. So whatever the domain was for the original function switches and it becomes the range of the inverse, and whatever the whatever the range was for the original function switches, so that they are no longer the same for each one, they're the opposite. Okay, so that's when you have a list of points. Now, let's say you have an equation, and this is where I think it's a little fun. So we have f of x equals 2x minus 5. Okay, and if we look at this line, the graph of this line, we'll do in just a second. It's got a slope of 2, it's got a y-intercept of -5, so we can kind of picture it in our minds. Now, I'm going to replace this f of x with y just to make my life a little bit easier because it's simpler. Okay, so we just want to remember that f of x is the same as y. Okay, and we want to find the inverse. So what we're going to do is we're going to take x and y, and I'm going to replace y with x and x with y. And then the rest of my equation is going to stay the exact same, except for now I'm trying to solve for my y value. Okay, so before we had y equals 2x minus 5, and now we're going to solve for y this time. So now we're going to add 5. Okay, those are not like terms, so I leave it like that. And then we need to divide by 2 because I'm still solving for y. Y is still not by itself. And then I need to divide this whole side by 2, so I could leave it like that, or I can make it, x over 2 plus 5 over 2. There's a variety of ways, but those would cancel over here, and we would have y equals this. So my function is this. And then the way that we write the inverse function is we write, instead of f of x, we have f inverse of x. So that is said f inverse of x. Okay, and that's what that -1 means. Okay, so that's the terminology. So that is this. We have x over 2 plus 5 over 2. Okay, so now if we wanted to graph those, and see what their equations look like, we could type in, let's go ahead and give me a little bit more space. So we have the first one was y equals 2x minus 5, okay? And then the second one, instead of f of x, again, we can just shorten this to be y for sake of Desmos. So y equals, now my slope is x, is not x, it's 1/2, but I can go ahead and just say x over 2. Okay, I need to move my cursor so it's now outside of that so that I can write plus. And I can write 5 over 2, or I can just write 2.5. Okay, so now I want to look at these graphs and see how they compare to each other. Okay, so if we zoom out, okay, they are essentially a reflection of each other, and they cross at that point. Let's see, where do they cross? They cross at 5, 5. So we could do a systems of equation and see where they would cross. Okay. So now let's try it again, but with a different function. Okay. So we've got f of x this time is going to be x squared, but we're going to do a piecewise version of it and say that we just want it when x is greater than or equal to 0. So let's go ahead and picture this function would look like a parabola, right? And it would be centered on the origin, but they're saying we just want it when x is greater than 0, so when x is over here. So we're not going to do the left side, okay? So we're essentially saying, don't worry about that. We just want this side, okay? All right, so I'm going to erase that. Okay, so we're going to try to figure out what the inverse is. So we want to find f inverse of x, okay? So again, change that into y equals x squared, and then we're going to flip the variables so that wherever y is, there's an x, and wherever x is, there's a y, okay? And now I want to solve for y. So in order to do that, I need to square root both sides. Okay, the square root and the square cancel, and I'm left with square root of x equals y. And again, we have that condition that x is greater than or equal to 0, which is good because our domain for that is the same. Okay, so my f inverse of x would be when the square root of x. Okay, so we take y, replace it back with f of x, and we're good to go. So now let's see what that graph would look like for these. Okay, so we have y equals x squared. And again, we're only going to be looking at the right side of this. So I'm going to try and move the graph. And then y equals the square root of x. Okay, so let's zoom in on just the right side. Okay, and you can see, again, these graphs, they are reflections of each other, and there's a line going down right in the middle. And they happen to cross at 0, 0, and it looks like they also cross again at 1, 1. Okay, so in order to find the inverse of a function, you switch x and y. Well, and if there's no y, just remember that that's the same as f of x. And then you solve for y, okay? And then that will end up being your inverse function. Okay? That's it for today. Go ahead and start on the homework. I want you to work on questions 1 through 6 on page 558. And then also number 7 through 15 on page 559.